Okay, seems like it's working. I don't know why it does not work before. Okay.
Professor, it works well.
Okay, yeah, somehow it was blank. I created before, but then it's a blank, so I just make another one.
Okay, should I send them this link? I can send them.
Yeah, you can send the link to them and yeah, just ask them to fill out. This is a way to see how they are doing. Where is PK? So it seems like we are back from the room. So I didn't hear the announcement. So is there anyone who want to present what you have done?
I guess I could, if that's all right.
Yeah, that should be fine. Yeah, which slide should I go to?
Right there, group 4.
Oh, nice. And then your name is?
Ahmed.
Okay, yeah. I have really bad accent, so
Fine.
forgive me. So yeah, let's move on.
So our group decided that the sensor is the float, the actuator is the inlet pipe,
Okay.
the
Yeah.
plant is the water dynamics filling of the tank, and I guess leaving. The controller would be the valve link and I guess float.
Yeah. That's a controller. I have the same opinion.
And then reference. I was gonna say references is desired water level, and
Yes.
disturbances can be anything from leaking of the pipe, grime or mildew buildup in the valve or inlet pipe or emptying mechanism. If the float starts sinking, or if there's a crack in the toilet bowl, and then output is when water leaves the tank through the empty mechanism.
Yeah. I think I have almost the same concept, and I think the instruction may not be clear again. So I also wanted to see the functional block diagram with these components. So I think it would be great if you can also add functional block diagram when you submit.
I missed that. I'll do that now.
Okay. Oh no, no worries. Thank you for sharing. Is there any comments, feedback from the class? Or do you want let me know if you want to present your functional block diagram to the class.
I have like a comment / question, I guess.
Yeah.
Yeah, so I was just gonna say the disturbance should be what do you call it? I'm sorry, the reference should be the change in the float, the change of height in the float. The higher the float is, the less water it brings it in, and the lower the float is, the more water it brings in.
Okay. Any like, so I want to have more like the discussion. So his comments is the reference should be height or
The height
change in height.
of the float, so the sensor. So
Yeah.
depending on where the sensor lies, you know,
Mm-hmm.
that's how much water will be brought in the system.
Yes. Um, any comments from other students? Any comments?
Can you elaborate on that, Arsalan?
Yeah,
Like,
yeah. So since
reference,
float
like,
itself, yeah. So since float is a sensor, right? The change in the height of the float would be the reference. So the higher the float is, the less amount of water gets inside the system. The lower the float is, the more amount of water gets inside the system. So it changes with the height of the float.
So I don't disagree with that. I guess that's the more the mechanics of the desired water level, like how the water level gets to a specific level. While the
Yeah, I know,
rest,
but sensor is the only input that gives you that desired level. Like without a sensor, there is no external what do you call it, input of water, right? There's no other way the water can come in.
well, the water would come in regardless, right? The float.
No, if the float is all the way to the top, the water is not going to get in because the sensor, which is float itself, has already sensed that, oh, the tank is full, so do not send any more water in, through valve.
I agree with the float sensor idea.
Yeah, it's like a float sensor. But reference can be to DJ. So I think the both of you have valid points. So like so when you design this toilet system, you design this part. Well, I don't know. You can see this part. If I say this part, yeah, I really want to have in class session. Draw. Okay. So like this system, like especially in this float, is designed to have desired water tank level. So the stage like height is, could I have your name? I want to learn the name actually.
Arsalan,
Uslam's, yeah, I agree with the Uslam's idea that it's the desired height of this float. But it's the same thing as like desired water tank level. So when you design, actually we need to have more specification, but this is also correct concept. Any comments? Also, I can be wrong. So any comments? I'm the toilet system designer right now. Comments? I think this was a very good discussion actually. Yeah, I think I give the extra credits for this. And yeah, he also had a functional block diagram. Yes. I think this looks good for me. Because we don't have enough time, I go to the Laplace transform. So Ahmed, do you wanna also show the Laplace transform you have?
this is our group member Yusuf solved this. And just going down the Laplace transform, I did it differently. I'm not gonna lie. I made a table differently. So,
I
put.
see.
Are we able to do this Laplace different from your lecture?
Yeah,
As
it's totally fine. There are like numerous methods. I just pick a method which maybe work well. So it's totally fine. So which is your slide?
well, that's I guess if Yusuf would like to explain this, what his work is, because if I try to explain it, I don't want to butcher his own work.
Okay.
So just looking at the chart of the Laplace transform, I just converted all the was into
the equation into the Laplace transform, I guess, and then I just went down plugging in the initial conditions, and
Yes.
then going from there. I might have made a mistake on algebra. I don't know. I'm not sure, but does that look
Yeah,
good?
I also don't remember exactly the answer, but what I wanted to say exactly is that actually, eventually, the MATLAB can do this work for you. So you don't need to really work too much worry about the algebra.
Okay.
It's good thing about having these days MATLAB. So I want to check whether actually you can do this, and then you can apply the initial condition. And you did well correctly. So this is fine for me. I give a full credit for this.
All right.
If
Sounds good.
any comments, questions, feedback? Or if you have any other thought, like let me know. If not, I think I will go over one more kind of a quick example of this. And then we conclude the lecture. So this is one example. And let's say, hopefully this works now. No, oops. No, I don't want to go to this. I want a slide pen. So let's say this is A and this is B. So this is real axis, imaginary axis, and this is A, which is -1. Which is B, which is -1. It should be B, which is 1, and then A, -1. And then we want to evaluate Fs when S equals J, means that S equals 0 plus J 1, means that it's here. So there are actually, again, several ways to calculate the outcome of this Fs, which is you can actually plug in everything here and then calculate. Another method which actually I showed during the lecture was having this vector and look at the magnitude, which is in this case should be SQRT2 √2, and then angle. You say this is theta 1 and theta 2. So I believe theta 1 is 90 plus 45. Theta 2 is 45. So what happens is that you can actually calculate. So K is constant. So there's the magnitude is K and angle is 0. And this part, the magnitude, so J plus 1 is this part, actually theta 2. So magnitude is this value and the angle will be theta 2. And this part will be here, theta 1. So magnitude is √2, and the angle will be theta 1. So then we can look at only the magnitude part. This magnitude part first, which is √2 and √2, and sum the angles, which is 0 minus theta 2 minus theta 1, becomes K divided by 2, and the angle will be 0 minus 90 minus 0 minus 55 minus 90 minus 55 becomes this. That's 180 degree. So if we evaluate this function at s equals j over here, the value becomes the result components number is k over 2, and the angle is negative 180 degree. So do you have any question about this? Any comments, questions? So this maybe looks very simple right now, but it becomes very important when you design actually controller again. Actually, let me, wow, it looks really. So even like, let's say we can also evaluate, so it means that we can evaluate this, even other data points here. Yeah, actually I can show some, I can provide you some book examples actually. And I can post this for sure, but my handwriting is not that great. So feel free to ask questions if anything is not clear. And let's say this is S2, and then it'll be the same thing. Let's say we want to evaluate the same thing at S equals, let's say 2J. Then we draw vector to here. And then look at the magnitude and angle. Theta 3. And I think I just remove this guy. And then theta 4. And then do the same thing. Calculate the magnitude. So it'll be K divided by M1, M2, and angle will be 0 minus theta 3 minus theta 4. And you can easily calculate this. And you find that actually this will be, the angle remain the same. It will be K, M1, M2, and then negative 180 degree, because these are symmetric. Okay. So this is a T250. So I think I stop here. My point, the last point is that you can do the same thing even for other, the general S equals sigma plus J omega. So let's remove everything here. And then you can just draw this vector and then calculate magnitude and then calculate angle and plug into the FS, and we get the answer. Okay. And this is for today. This slide, I just made this slide only for the live session, but I post only this slide to the Blackboard as well. And actually, the similar examples, actually, I didn't, yeah, you need to look at the pre-recorded lecture to see all this distribution and the theoretical background, because this is so important. So I just did everything by hand, very slowly. Any other questions? If you don't have any.
Hi. Just really quick, my team didn't get to click on the link that was provided for the Google Docs, so we just did our work on a paper. That's fine to submit, right?
Yeah. So you can submit your work on the Google Doc, and you can submit for the quiz. Submit your quiz result. We look at your submission, the grade scope submission.
Okay, thank you.
Any other question? Yeah. So this is the first of a different live session. Hopefully the second live session can be better. And thank you for your understanding. And yeah, and then feel free to ask questions on Piazza, so therefore everybody can get a benefit.
Professor, just real quick, if we
Mhm.
solve differently from our lecture notes, we can still get full credit for the steps.
Could you say that again? I'm sorry, I didn't hear
No,
exactly.
if we solve the part 2 of the quiz,
Yeah.
but it's not the same method as your lecture notes, but it's
Well,
still the
yeah.
answer, can we get full credit?
Yeah, I think you can. I think another method is like actually you can take integration. Like you can actually apply the Laplace operator. That's maybe you selected the method. Yeah, you should get full credit for that
Okay,
effort.
thank you.
Yeah, yeah. So the table is like to make the job easier table, and actually you can start from the original definition.
Professor, I got a question. I think somebody already asked it in the beginning of this lecture, but I just want to clarify that question that you posted on Piazza is in fact the review question 1.4.
Oh yeah.
Okay, sounds great. Thank you.
Yeah. So yeah, please, like if you like it's a question related to homework or something, maybe can the all the students may have like interest in it, please post on the Piazza. I saw the question on Slack and I just posted the answer on the Piazza.
Okay, thank you so much. Yeah, no, I guess everybody pretty much I think has edition 7, where we don't have edition 8, so I don't think a lot of people have access to that.
Yeah,
So maybe
yeah.
whenever those the homeworks are posted, could maybe we get the actual question with that too?
Yes. So actually, I think the homework 2 is already on the Blackboard. Actually, I wrote all the questions for you. I understand.
Professor, I think
Yeah.
I can make your life easier. I have a PDF of the 8th edition. I can share it if,
Wow.
yeah.
Is it allowed?
That'd be really great, Ahmed.
Or even if I can't share it, just tell me which pages you need and I'll screenshot and I'll post them.
Yeah. So we like I think I didn't hear so far, but any contribution will be really helpful.
Okay. If you can just post like or you know what, if it's already posted, I'll just try to do it today then. Yeah.
Okay.
Hey,
Yeah.
Ahmed, if you could just post your email address on Piazza, and then we'll just contact you from there.
Well,
Oh
that's great.
yeah.
I have emails.
Well, yeah, maybe you can use Slack. Yeah, just like
Yeah.
talk through Slack. I think that will be also easier.
Yeah, I'll post my email on the Piazza in case the TA professor needs to email me, and
Yeah.
for that reason only.
And also maybe TA will be also very appreciated. He doesn't also have the version 8. So
All right, perfect. Yeah, I don't. We never had this conversation. All right.
okay, great. Thank you. Any other questions, comments? Okay, then this is it for today. And then I see you on Wednesday. Bye.